Hello, welcome to Not for Exam. I am your host Sujit and we are going to calculate moment of inertia of some typical rigid bodies. Moment of inertia of a single particle of mass m and radius r for rotation in a circle of radius r is simply mr square. Moment of inertia of discrete system of two particles perpendicular to line joining them is sigma mi square, that is m1 r1 square plus m2 r2 square. Moment of inertia of a uniform ring of mass m and radius r about its central axis. This is a continuous system. Moment of inertia will be integration of r square dm. Here for ring r is same for each element, so we get I is equal to integration r square dm, that will comes out to be mr square. Moment of inertia of a uniform disk of mass m and radius r about its central axis. Assuming disk as a combination of differential rings of radius x and width dx having mass dm, that is mass per unit area into area of the ring. Now moment of inertia of the differential ring about the same axis is di is equal to x square dm, and by using superposition principle total moment of inertia is equal to integration of di, and solving the integration gives I is equal to half mr square. Now moment of inertia of a uniform rod of mass m and length L about its perpendicular bisector. Contribution of element of length dx is x square dm. Then total moment of inertia will be integration of di with proper limits, and you can easily solve it to get I is equal to 1 by 12 ml square. Now moment of inertia of a uniform rod of mass m and length L about an axis passing through one of its end and perpendicular to the rod can be easily calculated as above, but only the limits of integration are changed. After solving, you get I is equal to 1 by 3 ml square. Moment of inertia of a uniform hollow sphere of mass m and radius r about one of its diameter. Take a differential ring at an angular position theta and angular width d theta. Its width is r d theta and radius is r cos theta. Its mass will be mass per unit area into multiplied by area of the strip, and its contribution in total moment of inertia is dmr square. And total moment of inertia I is integration of di, that can be easily found by solving the integration, which comes out to be 2 by 3 mr square. Moment of inertia of a uniform solid sphere of mass m and radius r about one of its diameter. Take differential part of solid sphere as a hollow sphere of dr thickness and having radius r. Its volume will be dv, that is 4 pi r square dr, and by multiplying with density we get dm is equal to m upon 4 by 3 pi r cube into 4 pi r square dr, that will be 3 m upon r cube into r square dr, and its contribution in moment of inertia is di, that is 2 by 3 dm r square, and integrating di with proper limit gives I is equal to 2 by 5 m r square. Moment of inertia of a uniform right circular hollow cone, mass m, radius r, height h, and half cone angle theta about its axis. Take differential part of the cone as a ring in the form of a strip at a distance h from the vertex in ds distance, and its radius is r is equal to h tan theta, and width is dl, that will be dh upon cos theta. Integrating contribution di of this ring to get net moment of inertia, that comes out to be half mr square, which only depends on total mass and radius of the base. Moment of inertia of uniform right circular solid cone of mass m, radius r, height h, and half cone angle theta about its axis. Take differential part of the cone as a disc at a distance h from the vertex having thickness dh, and radius of the disc will be h tan theta, and integrating the contribution di of this disc we get total moment of inertia comes out to be 3 by 10 mr square, which only depends on total mass and radius of the base. Moment of inertia of a triangular lamina of mass m and height h about its base. Take differential part as a strip parallel to base and at a distance h from the vertex and width dh. Each element of this strip is at a distance h minus h from the axis, and use property of similar triangle to relate length of this strip with its distance from the vertex, and by integrating di you will get I is equal to 1 by 6 mh square, which depends only on mass and height of the triangle. Thanks for watching Not for Exam, and we will see you next time.